Hey y'all, my name is Noah. I'm one of the TAs for EA4, and I just wanted to take a little bit of time to introduce y'all to an online typesetting program called Overleaf, which uses LaTeX, LaTeX, if you've ever heard of it, in order to make more aesthetic documents for presenting math. This is something that we are not requiring for the lab reports, but it's something that could definitely benefit taking the time to learn, especially right now in your academic careers. As students who are in an engineering school, in an engineering program, taking this class, in the future, you will most likely have to collaborate with people and present information to them in a sound way. Of course, this is a low stakes situation that we're in, where we're in a class, in a controlled environment, doing lab reports. But I think learning something like LaTeX and using Overleaf to get to that point is invaluable to your careers in the future. And so I want to take a little bit of time just to introduce you to the basics of it. I'll walk through a couple of different tutorials. I'll provide some additional information and additional resources, some online documents, some YouTube videos, things like that. But Google is your best friend throughout this entire process, as you probably all already know at this point in your academic careers. Googling does wonders. So I will now start with all of that. Hey, this is Noah from the future, post-recording and editing, and the video is a lot longer than I thought that it would be, so just know that you do not have to watch the whole thing. Use this as a tool to help you actually get started using Overleaf, or if there are things that come up as you're learning it using other resources that you want to maybe see explained, come jump in here. In the description of this video, I have each of the different sections outlined and the timestamp for where it starts. You could also scroll along the length of the video and you will see those sections appearing there. Again, just use this as a tool to help you out on your Overleaf journey. This is not something that is fully necessary to watch or fully necessary to actually implement for all of the labs, though I highly recommend. So when you register an account through Overleaf and step through all of the steps to log in, this is probably the first screen that you will see. Of course, you could click this little Learn LaTeX with tutorial. If we do that, there's a bunch of information here. Scroll through it, look through it. There's videos, things like that. It's definitely a great resource. But I want to just open a project and let's name it EA4 discussion and see what happens. If we do that, we see that there are two sides to this screen. There's this left side where there's something that looks like code, and a right-hand side where there is a document. And if we do kind of a comparison of the left and right, we see that we'll skip these first two lines for now, but we see that we have this command that's in blue with the word title, and EA4 discussion is in curly braces. And if we compare to what we see on the right-hand side, there is a title, EA4 discussion. Same thing with author and date. We see those same two things. And if I were to change let's put today's actual date. Today's 20th of January, 2024. Now what I'm going to do is click this button up here, the recompile button. If I do that, you see it loads for a second, and we just went from January 24 or whatever was written there before to exactly what I put in between those curly braces. So in LaTeX in general, there are a couple of different types of words that you might use, and they will highlight in different colors. So the basic text that we have will mostly appear as black on this left-hand side of the screen. If we use a command like title or author, those will typically appear blue. And then other keywords are usually highlighted green, and these might be explicit commands that you put in these environments. So if we look at this, line 8 and line 14, we have a begin document and an end document. So anything that we write in here, and if I recompile, which I'm not going to keep clicking this button, if you highlight over it for a second, you see Command Enter is the keyboard shortcut to get there. I put, hello, this is me writing something out underneath this section for introduction, and we see that it appears on the right-hand side of the screen. So it's just like any other document editor that you might use, like Microsoft Word or Google Docs. You could indent and say, recompile. We get an indent and it writes it out. So at its core, it's pretty basic. It's pretty intuitive, but there's some nuanced things that I want to walk through. So before I continue, let's again look at the screen that we have in front of us. So we have this side, which is the code editor. We could click this button too, which is the visual editor, and it kind of walks through how it might appear on the right-hand side of the screen when we recompile. This is almost like a Jupyter notebook in some ways. Typically, I use the code editor, and throughout the duration of this discussion, I will be using the code editor. There's a couple of other options at the top too. You could choose different texts, which we'll walk through how to actually write it in code. Bolding, italicizing things, inserting different math, symbols, things like that. Figures, tables, lists. We'll walk through how to actually implement all of them in code, but this is always an option to use. So that's the code editor on the left-hand side of the screen. Again, on the right-hand side is the PDF that when you recompile will appear exactly how you wrote it over here. On the left-hand side, there are two rows in this skinny little column. Here we have the folder that kind of acts as our directory for the workspace that we're working in. So I could click any of these buttons to add a new file, a new tech, or you can add a bibliography file here too. So there's multiple file types, but we're just going to focus on the tech for this introduction. You could add a folder. This could just be used for organization, and you could upload images or other files, anything like that, and it will all appear in the space here. So because this will come in handy a little bit later, I'm going to add an image of Taylor Swift from the Golden Globes. And we see that it appears in our workspace. If I click on it, we get a preview of what the image looks like. But what I'm going to even do, just to keep organized, I'm going to put this image in a folder that I'm labeling images. This just makes it a little bit more organized as we move forward. The other part of this column is a file outline. And so as we add new sections or subsections to our document, the outline will automatically recognize that a new section has been added and will fill it in there. So let's just do that. If I, all the way on the left-hand side of the screen, add another section using that command, \section, curly braces, and I write, and let me just say, and I recompile, we see that on the right-hand side of the screen, we have these two sections that have appeared that are automatically numbered. And it even appears on the file outline on the left-hand side of the screen. If I were to click one of these, click the introduction, you can see my cursor moves up to the introduction. If I click moving forward, it moves to where that section starts. Just like using some coding software, we could also collapse the different sections just to make it a little easier visualizing all of this. Okay, so let's actually get into the core of Overleaf. So I want to talk a little bit about just the aesthetics of the page right when we open a document and how text works in Overleaf. So you might notice that I've been double indenting between paragraphs. And that's because if I were to just move to the next line and write something out and recompile, even though I returned on the left-hand side, Overleaf doesn't recognize that this is what's happening, and instead will just continue the text next to the last sentence. So in order to actually get it to be a new paragraph, I need to do two returns. This is also easier to visualize when you are writing long paragraphs of text. Having two spaces between them just makes it easier on the eyes. You might also notice at this point that I moved down two lines and did not indent, yet over here an indent appeared. This is something that is unique to LaTeX and Overleaf. We're going to learn some workarounds to format the page how we want it to be formatted, but just know two things. One, double returns in order to create a new paragraph. And number two, the first paragraph after a section is not indented, and every other paragraph after that is indented. You can indent and write something over here, and it will also indent. But as this text gets longer and longer, the entire line is indented in the code editor, but when we actually recompile it, it isn't fully indented. So this is something that I wouldn't recommend doing. I say just stick with keeping all of your lines flush up against the left-hand side of the code editor. But again, you'll develop your own habits throughout the course of learning this program. So whatever you decide is best for you, that's what you should do. Okay, so just a little bit more information about the code editor itself and the different parts of a LaTeX document. There are two sections. There is this main body, the begin document to end document, which is what we write in to actually get text, images, tables, anything to appear in the PDF upon recompiling. And then there's also this preamble, it's called, where we will specify things about the document itself. The first line, whenever you start a new Overleaf file, will always be this document class specification. An article will typically be the thing that you're writing with, but just know that there are multiple classes that you can put in there. Things like memoir or book or letter. But article is what we're going to be using in this write-up, and it's what you should be using if you decide to use this for the lab reports in any way. Then there is typically a series of these package declarations that you are going to use in the file itself. So we can see that the first command that we have here is use package graphic X, and this is what's required for inserting images. So now I'll also note that using the % is a way to add comments. And when I recompile, even if I write a comment in the body of the text, nothing appears on the right-hand side of the screen. So this preamble, this declarations of using package, if you know Python, it's kind of like importing different modules into Python. So as we move forward, we're going to be adding new packages. But before we do that, I still just want to talk about the plain old text that we have in the document itself. If we wanted to bold or italicize some writing, if I just click this, you can see that a command comes up, \text_bf. So again, at this point, we've seen a couple of different commands that have been written, and they're all written in the same way. A backslash, the name of the command, and then an open and a closed curly bracket. This is the formula for any command that you're going to use in Overleaf. So text BF, text boldface. If I recompile, you can see that it appears on the right-hand side of the screen in boldface. We could click the italic and use that as a way to add the italics to the document. But I also just want to show that you could write this out yourself. So if I follow the same formula for the text boldface, if I do \text, I get a couple of options. The first one is this boldface. The one right underneath it is IT. This is the italics. If I recompile, we can see that it appears on the right-hand side of the screen in italics. If I were to write a sentence that might have needed boldface and italics, this is how it might appear. Now we can see that when I recompile, the sentence appears with just the words that I put within the curly brackets as boldface or italics. The one other command that you might want to use while you're doing some writing is the underline, and it's not going to be text UN or anything like that, because if we try doing that, UN, nothing appears. If I recompile, we see two things that happen. One, this whole thing's highlighted red, and if we look at the PDF itself, it's not underlined. So this flags that, okay, there is a mistake. And it tells us, if I go over this little red dot, that there is an undefined control sequence. At this point, I want to say two things. One, clearly, text UN is not the thing that we're going to use. We're going to use the command underline. Number two, recompile the PDF quite off. As you add new text to your document, or might use a new command or anything like that, just recompile. It doesn't take a long time for it to happen. And so catching mistakes will become a lot quicker if you recompile often. So underline is the way to underline words, text BF boldfaces words, and text IT italicizes words. So we've seen that we could add sections to the entire document. Let's add a subsection right now. When I recompile that, you can see that we get exactly what I wrote in the subsection in the curly braces appearing on the right-hand side of the screen, subsumed under the second section moving forward, and it's listed as 2.1. I could also do a subsection, changing the size of words, and again, we see that that's subsumed under 2.1, which is subsumed under 2.2. And if we go again to this file outline that appears on the left, you can see the way that it creates like a tree structure of the different sections, subsections, and subsections of the entire document. So let's actually try to understand how to change the size of words. This isn't something that I think will come up often, but it's something that I think is worth mentioning. Okay, so I've just copy pasted from another document I have an example of using two different commands. One of them is huge and the other is tiny. If we look at the PDF, what ends up happening is we get large text or we get tiny text. And in order to actually get the compiler to understand what words to make big or small, we have to change where we put the curly braces. So at this point, a good thing to note is that there is a difference depending on what command we're using, where the placement of the curly braces goes. For most commands that we use, it will be that the word or the object that you want to be specifically impacted by a command will be in curly braces. But huge and tiny are examples where that's not the case. So like I mentioned at the forefront of this video, Google is always your friend. It's as simple as just saying, if I just Google how to write text that's bigger than the other text around it in Overleaf, that's a pretty long Google search, but look at the first thing that comes up. If I click it, this is exactly what we were curious about, and we can see the placement of the curly braces. Also note that this is directly from Overleaf. So this is it with the brief introduction just to text in an Overleaf document. I'm going to scrap all of this right now, and let's start talking about math and writing math in Overleaf. So section, I have a master document that I wrote on that I will share with everybody, the tech file and the PDF itself, just so you can go back and look through all of it. So everything that I just deleted, I'll make available to you in a nicer typed up way. So in order to write math in Overleaf, we need to use different environments. And there are a couple of common environments that we might use to write math. Those will be the equation align or multiple line environments. And let's start with that first one. An environment is a little different than a command. A command is something like what we saw before with this text boldface. This is a command because you are changing something that you input within the curly braces. And an environment, on the other hand, usually starts with the keyword begin, just like begin document. And if we type in equation and click enter, what we'll see happen is it's closed at the end by an end equation. Now I could write math in here. And Overleaf kind of uses a mixture between shortening words and using the words themselves to actually write the math out in the way that you might expect the math to be written out. So for example, if I want to write the sine of theta, the way that I would do this is I would use the backslash command, sine, curly braces, and then I'll also put parentheses in there just for aesthetic choices, backslash theta. And if I click and recompile it, we'll see a sine theta appear. And what's more is it's numbered as equation 1. This is the first equation that appears in the document, so it's labeled as equation 1, just as the section math is the first section that appears in the document, and so that section is labeled as section 1. So LaTeX and Overleaf keep track of exactly what equations are written when, what sections are written when, and as we'll later explore, the same thing will apply for figures and tables. So let's spruce this up a little bit. So I've just written out a little bit more because when we add an equation to a document, it's usually within some context. So I just said sine theta is defined as the ratio of the length of the opposite leg over the hypotenuse in a right triangle. Not reinventing the wheel here, but a new command that I just used was this fraction in the equation environment. So as has been consistent with all of the other commands that we've used, we do backslash frac, and we use two sets of curly braces in this case. The first set will be the numerator, and the second will be the denominator. So let's see this out a little bit more. So I've just added another equation to the document, just a basic integral that I've put in the equation environment. So in order to get this integral sign to appear on the right-hand side of the screen, I use the command int. Squares or any other powers appear using the caret symbol. And again, frac takes in two arguments, the numerator and the denominator, both of which are wrapped around in curly braces. Weird things can happen if you misplace text or don't entirely close or use the curly braces correctly. Like if I accidentally write this 3 outside of the fraction and I recompile, you can see that on the right-hand side, this isn't appearing how I want it to appear. I want it to be 1/3, and instead I have the 3 appearing like it's being multiplied by the x cubed. So if I notice this on this side of the document, I have to try to find where I am on the left-hand side of the document, so in the code editor, from the PDF to the code editor. And these arrows right here are basically the way that you can go back and forth between the two. So suppose I have my cursor at this sine theta. If I click this top button, you can see it highlights exactly where we are looking. And the same thing is true going backwards. This is a very small document right now, so I don't know where it's going to go if I click to the left. Yeah, it just went to the end document. So if you double click on a certain word, it will bring you to the line where that word is written. So you can see if I click relationship, I've now moved, my cursor has moved to line 14. If I double click on suppose, I've now moved to line 19 where suppose is. So this left arrow isn't necessarily the most useful, and what is more useful is actually just double clicking where you want to go to in the code editor itself. So let's write a little bit longer of an equation just so we could try to really understand how these curly braces are working in these different environments. So I've written this longer equation where I've changed from the square of a sine to a relationship with the cosine. And if we take a look at the output, the PDF, it looks good. And so let's understand the structure of the equation itself. This is where it gets a little tricky to keep track of all of the parentheses or curly braces and things like that. And so it's best to take it slow, break it down component by component. And if you're not getting it to appear exactly how you want on the right-hand side of the screen, sometimes starting fresh is a good way of doing it. But what's good is if I were to put my cursor next to one of the curly braces or parentheses, I get the left and the right to highlight at the same time. So you can see, even though my cursor is only next to this closed parentheses, with my cursor being there, the left parentheses is also highlighted. So I could see exactly what's being enclosed by those parentheses. The same thing goes for the curly braces. So what this is doing is it's using this parentheses pi x as the argument to the sign. If I were to get rid of these parentheses, it just makes it a little bit more confusing about what's actually being input to the sine function and then being squared. So I always like using parentheses when I use the trig functions. So now moving over to the fraction itself, I have a numerator and a denominator just as I had before, but instead of being just one value or one letter as I had in equation 1 or 2, here I have a more full numerator. So I have 1 minus cosine, and same as how we took care of the sine squared term, I have the open and closed curly braces as what I'm going to be inputting to the cosine, and then I use parentheses around the argument 2 pi x. So let's explore these curly braces just a little bit more so we can understand the way that they might behave in different situations. So with the fraction or the argument to the sine, it's pretty intuitive that whatever's in the curly braces is what's being used in those locations. Anything in the first set of curly braces is in the numerator of the fraction. Anything in the second is in the denominator. But what if we're trying to raise something to a fractional power? If I were to, before I recompile this, take a guess at what you think might happen. So what I've written out is that x raised to the half power is equal to the square root of x. Note, this is a new command. Backslash sqrt is the square root, and we use curly braces for what will be under the radical itself. So what do you think will be the output of this when I recompile it? If I recompile it, you can see that on the right-hand side of the screen, the only thing that x is being raised to is just the 1. So after the caret, the first character is what's recognized as being raised, unless you wrap everything around curly braces. So if I recompile this now, you can see that 1/2 appears in the superscript location next to the character x. So this is what we want. So what I'd recommend, even if you're using one character, it's good to be consistent throughout an entire document. And so wrapping anything that might need to be wrapped in curly braces is a good rule of thumb. Let me also just make this equation a little bit longer so we can understand how the square root is also working. Recompile that, you can see that anything that's within the curly braces for the square root is what appears within the curly braces for the radical on the right-hand side in the PDF. So it's pretty intuitive. I hope at this point everything is making sense because anything that you write, just like how you might code, is exactly what appears when you actually recompile or run a program. So using your intuition throughout the learning process is something that I think will really come in handy. And as you get better and better at using LaTeX, you'll pick up on these habits really quickly and it won't be an issue moving forward. But I mentioned that there were other environments for writing equations, and those were the align and multiple line environments. There's others, but these three are the typical ones that you might use. So I've just added some subsections to the document so that we can differentiate as we're continuing down. So the align math environment is used when we have a longer equation that we might want to show different steps out, and we want the equation to kind of walk down those steps. So instead of using equation environments back to back to back, we can just use the align environment. That being said, align is something that's not native to the standard or traditional basic Overleaf document. So what we're going to have to do is actually add another package to the preamble. So we'll go up to the top. You can see I'm at line 3 right now. Use package. AMS Math. This stands for American Mathematical Society. It just has a bunch of different mathematical symbols and the environments that I'm just talking about right now, the align and the multiple line. So what I've done is I've copy pasted an equation that's just taking the integral of cosine squared. It uses a trig function to simplify cosine squared down to just a relationship with cosine, breaks up the integral into two components, and then takes those integrals. So there's 3 lines here. And if we look at the align environment and the code that I've written on the left-hand side of the screen, we can see that there's also 3 lines. At the end of each line, I've used this double backslash to indicate that a new line is starting. And I don't include the double backslash at that last line because we're done then. There's no new line that has to appear. I have used basically all of the commands that we've talked about so far with the equation, this integral, cosine, square, wrapping things in curly braces, the fraction, but there's this new thing that I've added, the left and the right. What this does is it rescales the parentheses, the symbol right after the left or right command, to be as large as the height of the text that we want to be between those parentheses. So you can see on the right-hand side of the screen, these parentheses are as big as the fraction. If I were to get rid of the left and the right, what ends up happening when I recompile is the parentheses are just the standard height of the parentheses in general text, and it doesn't look as good anymore. I always recommend using the left and the right command, especially when you have a fraction. It makes it look better. I recompile. This is what we want it to look like. There's also one new symbol that's introduced in the align environment, and that's the and or the ampersand symbol. The and has to appear on every line. It does not need to appear once. We'll go through an example where it appears multiple times. But what the ampersand is it's a flag for the compiler to see that, okay, as we go from one line to the next, let's align those ampersands. So if we think about, if I tab this in a little bit, and I get the ampersands to actually line up, we have this integral of cosine being equal to these other things that I then simplify from one line to the next. And I'm aligned right at this equal sign. And if we look at what it looks like on the PDF, that's exactly what we see. The equal sign is consistent from one line to the next. There's nothing stopping me from moving around the location of the ampersand, like I can move it to right after the integral and recompile. But you can see that that shifts then the bottom equations, because again, just think about where that would place these bottom 2 lines if we line up all of the ampersands perfectly. It's not consistent. It's best practice to line up at the equal sign. But again, use your best judgment. It might change on a case-to-case basis, depending on what you're writing out, but the equal sign is a great place to start. At this point, you might have noticed something, that this whole align environment, it's only one equation that we're simplifying from line to line. And so the only really important part of this equation is this last line. Yet all 3 lines are numbered. If we only want this last line to be numbered, we can go back into the align environment and use the command no number with that little backslash and recompile. And what we see is the 2 lines that just were numbered are now no longer numbered. So since I wrote the no number before the double backslash, before I went to the next line, the line that it's at is this first one with the integral, and so that's the one that's not numbered. And then the second one that still has the integral symbols is also not numbered. If I were to include a no number on the last line, then we have an equation where there are no numbers for any of the lines of the equation. So I could do the same thing in the equation environment. If I put the no number command, we can see that that equation is no longer numbered. You can understand that this might become a little cumbersome if you're trying to add no numbers to a lot of different environments. And so an easier way to get rid of numbering lines is using the same environment that you might want to write the equation in. Like, let me just copy equation 3 into this subsection numbering lines. And what I'm going to do here when I recompile, I have this equation showing up again with a number. But if I don't want to have the number, if I add a star right next to the keyword equation in the curly braces, and I recompile that, the star is a new flag for the compiler to say, okay, we don't need to number this equation. So when I did recompile that, you can see that there's no number that appears. Without using the no number command, we can still get no numbers to appear if we use the star as a symbol for our environment. The same thing will go for a line. So I'll copy this equation down here as well, get rid of all of the no numbers, recompile, and we see that all of the equations are numbered. If I just go in here and slip in a star at the end of the word align and recompile that, then none of the numbers appear. So typically, the no number command is only used if you want, for example, the last line of an align environment to be numbered. So just the conclusion that you get to after the couple of lines, or if you want all of the lines to not be numbered, using the star is better practice. The align environment is actually really useful if we have a lot of equations that we want to show all lined up nicely. So I've just copy pasted a series of equations, and let's walk through what all of the symbols are doing in this before we actually recompile so we can try to guess what it's going to look like. So as I mentioned before, the ampersand is something that aligns from line to line, and the double backslashes are used to change from line to line. And I did just say that the align environment is useful if we have a lot of equations that we want to line up together. And so you might anticipate that since there are 5 ampersands per line, each of those will be aligned with the corresponding ampersand in the next line. What I mean by that is, for example, all 3 of these ampersands are going to be aligned. All 3 of these will be aligned. These 3 will, these 3 will, and these last 3. So if I recompile that, that's exactly what we see happen. The equal signs from line to line all line up. And we have a little bit of space between those equations. So introducing these ampersands between equations adds a little bit of padding. Typically, when we're numbering equations, what we want is the equations within a specific section to be numbered according to the place within that section. So what I mean is, since this is all within section 1 of the document, we want these equations to be 1.1, 1.2, and so on and so forth. And once we add a new section, we want it to be 2.1, 2.2, and so on and so forth. And the way that we can do that is by scrolling up to the top, going to the preamble, and using the command \number within. In the first slot, we'll say equation, and in the second slot, we'll say section. And if I recompile that, what we see is exactly that appearing, 1.1, 1.2, 1.3. And just so we could really see this in action, let me change the Align Math environment from a subsection to an actual section and recompile. And we see that this equation was listed before as 1.4, and it's now listed as 2.1. Because this has now changed to section 2. So I'm going to undo that, but now we have the numbering exactly how we want it to be. The other environment that I mentioned was this multiple line environment, which is written as Multline. I personally don't use this one often, but it's good if you have a really long equation that ends up having to be broken down onto 2 or more lines. So I've added this really random long polynomial to the document, and when I recompile it, you can see that it really does not look that good. We have this polynomial extending over this margin line, and as a result, the number of the equation has been pushed below the polynomial itself. If we look at the code itself, we have this yellow triangle that appears, and if I hover over it, we have this warning that there's an overfull H box that's a couple of points too wide. And what this is saying, this H box, is that we've extended beyond the margin of our page. and it was detected within this environment. So the way around this is by using the Multline command. I've used the exact same polynomial and wrapped it in this multline environment, begin multline, end multline. And I've just chosen a location to break the line by adding these two backslashes. And I've put 5 terms of the polynomial on top and 6 terms on the second line. And what we see in the recompiling of this in the PDF itself is that the first line is aligned fully to the left and the second is aligned fully to the right. This just helps visually break up the equation, and it's no longer throwing the error that we had before. So now I want to talk about something called inline math. You might have small equations that don't need to be written out fully in an equation itself in one of the environments that we just talked about. And so you might want to just include it in the text itself. And so there's 2 methods of doing this. One of them is using the $ and the other is using parentheses. So I'll walk through both examples right now. So I've just written out the Pythagorean theorem in a little bit of a verbose way. And in this scenario, we don't need to separate that c equals the square root of a squared plus b squared into a new equation. And so we just write it on the same line as the entire Pythagorean theorem. Using the $, we wrap whatever section we want to be written like an equation within those $. So you can see that I start with the $, right before c, and I end it right after the square root symbol. And if I were to not include these and were to recompile, what ends up happening is an error is thrown because the square root is something that's not allowed to be used outside of mathematical environments. The $ is just a way for Overleaf to recognize that we are using some mathematical jargon, and so italicize the output and use the proper symbol. So if we look at the PDF itself, we see that the square root appears, the squares appear exactly how we want them to, and the entire thing is italicized the way that in the equations themselves, they're also italicized. So that's one method of using inline math, is with those $. The other way, it's the exact same type of process, but we use a backslash parentheses. The left parenthesis is used at the start, and the close or right parenthesis is used at the end, and anything in between, it's recognized by the compiler as being mathematical, and so the symbols appear. So there's no difference in the actual output between these 2 methods. I personally like to use the parentheses. I don't know why, but I do. So there's a few other things that I want to talk about with the math environments themselves. I'll go over some symbols that are used within the mathematical environments, boxing an answer, adding text to the math environment, and just some other packages that have other symbols that are useful in the overall aesthetics of math. There are a lot of mathematical symbols that are included in the AMS Math package, and the main ones that you should know, or the main ones that you're probably going to use the most often, are like the Greek symbols and the arrows. At least those are the ones that I use the most often. So Greek symbols are very straightforward to use. As we saw before, if I scroll up in this document, writing pi was as easy as \pi. It's the same thing for any other Greek symbol. So what I've done here is I've written the first few lowercase and uppercase Greek letters, so alpha, beta, gamma, and delta. And it's important to note that the lowercase Greek letters are all written using backslash and then the name of the letter. So backslash alpha, the output is a lowercase alpha. But because the uppercase alpha is just the standard Latin letter A, there is no command for an uppercase alpha, and you instead have to use the letter A. That's distinct from something like gamma or delta, where if we just go from a lowercase first letter, this G in gamma, from going lowercase to uppercase, the output is the corresponding lowercase or uppercase Greek letter. You might note that I have included spaces between these letters, but the output does not contain spaces. And so a way around that is using the command \Hspace and adding something like 2 millimeters. And what that's going to do, if I just add it there, you can see it's now introduced this space between the lowercase alpha and the uppercase alpha. So you can see here I have staggered the spacing between these symbols a little bit. So I've added just 2 millimeters of space between the lowercase and the uppercase symbol, and then 8 millimeters of space between two distinct letters. So the output has the corresponding distances that I've hard-coded in. The other symbol that I use a lot is the right arrow symbol. So I've just added this basic equation where I go from 2x plus 1 equals 0. I add some space, add a right arrow, add a little bit more space, and then write that x equals -1/2. So the output in the PDF is exactly what I just spoke out, exactly how we hard-coded it. And this looks good. However, to make it look even better, we might want to actually box our final answer. And the way to do that in an equation environment is to just use this command \boxed around the thing that we want boxed. So I want my final answer of x equals -1/2 to be boxed. I recompile it. We see that it is boxed in the PDF. It's a little bit different if we want to do it at the end of an align environment. And so the way to do that is to actually include a new package within our preamble. It's going to be the package math tools. So once we add that package to our preamble, if we write some alignment equation, we're able to use the command aboxed with a capital A. That allows us to use the ampersand in whatever we actually want boxed. So if I were to get rid of this and just use the command boxed, we get a complete error that's being thrown. We're told exactly where this error is, but this error, when I move my cursor over the little dot that appears, it's not entirely clear what the error is. It's telling us that there's an extra curly bracket or we forgot to put a math environment in. So it's not entirely clear. That's why recompiling often is something that's good. And so what I might do in this situation, if I didn't realize that I needed to use a different command or use a different package, I'd look through my alignment equation and I'd say, okay, what's in here that's different than something that I've already written that compiled fine? Well, that's this boxed. So if I get rid of it completely and recompile, let's see what happens. It recompiled, the error is completely gone. So we know now that the error must have been in using the command boxed. So it's at this point that I'll open Google and I'll be like, how to box an equation in the align environment. And that's honestly how I learned quite recently that using the command aboxed is what you need to do. In certain mathematical contexts, we might need to bold a variable or add a symbol like a hat over a variable name or a tilde over a variable name. And it's pretty straightforward to do all of this. So in order to do boldface in a math environment, just like before we had text BF, here we're going to use the command mathbf. Here, all I've done is I've defined some vector v as being 1, 2, 3, and in our output, we see that the v itself has been boldfaced. In order to add a hat above a variable name, all you need to do is use the command hat and wrap in curly braces whatever you want to be hatted. Same thing goes for tilde, and same thing goes for this command overwrite arrow. In the output, you can see that those symbols have a hat, a tilde, or an arrow directly above it. If we want to include some text after an equation, it's just as easy as using the command text and wrapping in curly braces exactly what we want the text to be written out as. If I were to get rid of this and recompile, you see that all of the words are scrunched up right next to each other. Everything is in italics. This is not what we want it to look like. And so you have to include the command text around what you want to be written normally. The other package that I almost always include in the preamble of my Overleaf documents is the physics package. So let's use package physics. There are two main components of the physics package that I like to use. It's the derivative or the partial derivative symbol, as well as the evaluation bar. So let's use both of those right now. So for derivatives, what we end up having is we use dv for derivative, and the first thing that comes up, I'm going to click enter. In the square brackets is an input, and in the curly ones are the arguments. The input is a number that corresponds to the order of our derivative. So if we want to take the second derivative, we'll put a 2 in there. If we're only taking the first derivative, we leave it blank. In the curly braces, that's where you'll have the function and then the variable that you're taking the derivative with respect to. The exact same thing goes for the partial derivative. The only difference is I add a p in front of it. Square brackets, curly curly. This is the input. Let's take the second derivative of some function f of x, y, z with respect to y. If I recompile that, our output is this first derivative with respect to x and this partial second derivative with respect to y. However, this doesn't really look that good. So what I typically end up doing is moving the first argument, that function, outside of the curly brackets and moving it to the end of the last curly brackets. And what this does is it leaves the top blank in our derivative fraction. And if I recompile that, it's just put right next to it. And I think that looks a lot better aesthetically. The other thing that I said I used quite a bit is the evaluation bar. And this is typically what I use when I'm evaluating an integral, because this is what we typically write when we're evaluating an integral. So on the right, all I'm doing is taking this definite integral from 1 to 5 of x dx, and upon actually computing this antiderivative, I'm plugging in x equals 1 and x equals 5, and I get the answer of 12. So let's look at the code and see how this ends up playing out. So in order to have a definite integral, I use the int command, as we did earlier, to actually get the integral symbol. But then I use the underscore followed by curly brackets with the lower endpoint, and then a caret with curly brackets with the upper endpoint. So this has the effect of, if I change this to a 6, for example, replaces the 5 with a 6 at the upper part of this integral. I have this eval wrapped around this fraction. So what I'm saying is, at the end of writing out this, add a vertical bar with the lower point being x equals 1 and the upper point being x equals 5. And that's what we see written over here. Okay, I think this about clears it up for everything that I wanted to talk about with math and math symbols themselves. Let's start talking about the next topic. Okay, so now we're going to talk a little bit more about some of the aesthetics of the page itself. You may have noticed as we're going through all of this recompiling that the margins on the page are a little obnoxious, to say the least. And so we're going to step through a couple of different methods of changing the aesthetics of the page, and we're going to start with actually changing these margins and choosing what we want specifically. In order to change the margins, we're going to have to include the package geometry. So let's use package geometry. And then what we can immediately do after that is specify that we're going to be using this on A4 paper, which is basically 8.5 by 11. I'm going to say that the total width and height of the page are 170 millimeters and 257 millimeters, which is just the standard for A4 paper. We'll make the left margin 20 millimeters and the top margin 20 millimeters, and it'll automatically fill in then that the right and the bottom will also be 20 millimeters. You can specify different values for the right and the bottom, but if you just do the left and the top, it'll automatically assume that you want the same for the right and the bottom. So let me just recompile this. And we can immediately see that honestly, this looks a lot better. So the 4 other things that we're going to cover in this section are adding columns, changing the text color and highlighting, changing the font, and then finally indents and enters. So to add columns, we have to include another package, and this package is going to be the multi-col package. And I'm also going to introduce this new package too called blind text. And what this is going to allow me to do is just let the computer write like lorem ipsum Latin text, just so we can understand how adding columns looks, and I don't have to type out a lot of different things. To add columns, we're going to use the multi-cols package, and we'll also use that as the environment. We're going to specify the number of columns that we want next to this curly bracket. So let's start with 2. And here is where I'm going to use the blind text. And then I'm going to recompile. And when I do that, you can see that two columns appear with just dummy text. And I could increase the number of columns if I wanted, but if I do that, I'm going to add a little bit more blind text. We'll do 3 columns now, recompile. Outside of the multi-calls environment, once we start writing normally again, text spreads all the way across the screen the way that we'd expect it to. In order to change text color and highlight, we're going to use the package Xcolor. So I'll go back up to the top of the screen in the preamble, use package Xcolor, scroll back down to the end of my document, and now I could just use the command color. And let's start with red. Recompile, and we can see that everything after this command color red has now changed to being red. So if I wanted to change the color again, changing the color to violet makes it everything purple. And in order to actually get back to black, then I'm going to use the command color black. So now everything after this command on line 165 is black. Suppose instead you just wanted a specific word or small series of words to be a specific color. We can use the command text color, and it takes in 2 arguments. The first argument is the color, and the second argument are the words that you want to become that color. This line that I've written on 167 has 2 instances of the command text color. The first one, I've let red be the first argument and become red be the words that I want to become red. And then same thing for this violet, and the words that I want to become purple are the words become purple. And if we look over at the output, we see that only those 2 phrases are the ones that change color. This is a better way of changing color, and the color command itself could be used at the start of the document if you want the entire document to become a different color. If we want to create a highlight, we're going to use a command very similar to text color. So to create a color background, we use the command color box. That also takes in 2 arguments. The first argument is the color, and the second argument are the words that you want to be highlighted that specific color. So in this instance, in line 169, I have color box yellow as the first argument, and color box as the word that I want to have the background of yellow. And we can see in the output that that's exactly what happens. So now let's talk about changing the font. The default font in Overleaf is the serif font, and this is more than okay for any quote unquote professional thing that you're writing or for any of the labs that you might submit for class. The only time that I really do change the font is if I'm specifying a MATLAB function that I might have used where the word isn't necessarily a real word in the English language, something like linspace. So in order to do that, we're going to use the curly brackets, kind of similar to how we used the curly brackets when we were changing the size of the text using huge and tiny. So we use curly braces, backslash font family, and then specify what font family you want. QCR and then select font command will allow a different font to appear, and this is the one that I use when I'm trying to get the MATLAB function to change. So you can see that the typeface has changed to being more of a typewriter typeface. Finally, let's talk about indents and enters. An aesthetic choice that I personally make when I'm writing papers that you do not have to follow is that I really don't like the indents at the start of new paragraphs. I would much rather have them all the way pushed to the left and have an additional space between paragraphs. And so to do this, we're going to use the package parskip. And if I recompile that, you can see that everything has now moved over to the left. There are no indents anymore. And when I do have a new paragraph, like here, there is an additional little vertical space that appears. Similar to how we can specify different aspects of the package geometry, such as the margins on the left and the top, there are additional things that you could use for parskip, such as the vertical space that you do introduce between 2 paragraphs, but I don't typically change that. And that's something that you can look up on your own to see what commands you might need to use. Okay, that about does it for the aesthetics of the page. Now let's actually talk about adding images and tables to the document. In the majority of the labs that we have for EA4, there's going to be a necessity to use tables and images. And there's two ways of adding tables and images. We are finally going to click over to the visual editor. And if we do that and we click Insert Table up in this little menu up here, we could specify the length and width of the table that we want. So we're going to start here and then go back to the code editor to see how it was written and how we might implement it ourselves. So let me just make a 3x3 table. I will have the caption below. You could also have no caption or put the caption above. I'll have all borders. I'll name the first and then just add random values in here. And let the caption be random values. Okay, now if I recompile, let's see what happens. We have had the table jump up to the top of the page. It has lines in between all of the values, borders completely around the table, and it has the caption table 1 random values. Let me just go back to the code editor and let's look at how it appears in the code. So we have this table environment that we have the begin and end for. The first thing here is the centering command, which positions the entire table at the center of the page. And then we have this other environment within the table environment. This environment is called tabular, and it takes in an argument. This argument has the number of columns that we want specified through these Cs. Introducing the pipe in between the Cs and at the ends of the Cs is what introduces the border between different columns. So if I were to get rid of the one on the left, for example, and recompile, what I expect to happen is that this line here, if you can see my cursor, is going to be gone. So I recompile, and you can see that that's exactly what happened. Now, suppose instead I introduce another C. What that's going to do is introduce a whole new column to the page. But you can see that when I recompile, nothing happened. So let's look at what else is written in the tabular environment itself. Let me get rid of that just so we can actually try to digest it. So H line adds a horizontal line that spans the width of the table. And you can see that that's at the end of all of these lines. So that's what corresponds to the 4 horizontal lines that we see, again, with all of the borders between different entries in the rows. Much like the align environment, the ampersands are used as a way to distinguish between different elements of the table itself. What you should have when you produce a table are 1 less ampersand than the number of C's in the argument to the tabular environment. Since there are 3 C's here, meaning that there are 3 columns, I should only have 2 ampersands. If I put this 4th C back in the argument for the tabular environment and I recompile, again, we see that nothing changes within the table. And this is since there are only 2 ampersands, the compiler basically ignores this last extra entry. However, we could add another ampersand saying call 4, and then also adding ampersand 0 and maybe ampersand -1 to the other components of the table itself. And we see that it introduces those values to the table. I could also get rid of one of the entries, like I just deleted this 0, and when I recompiled, the 0 is gone from the specific entry that it should be in under column 4. So moving down beyond this tabular environment, there are 2 other commands, caption, and whatever you put in the curly braces for the caption is what appears next to table 1, or whatever table number you might be working with. And then there's this thing called label that appears too. So I'm going to label this a table of random values. This label becomes very useful if you mention the table somewhere in the writing itself. So instead of keeping track of what table is what, Overleaf does it itself. If I say refer to table ref tab, table of random values, and recompile that, we look under tables and images. It says refer to table 1 for a table of random values. I never said that this was table 1, but since I referred to the table with the label table of random values, Overleaf automatically tracked that that was table 1. So this is useful if for some reason you have this table here, but then you remember, oh no, I actually want to add a table somewhere else. So I'm going to scroll up to a random location and let's add a table manually. Begin table, enter, and it automatically fills in everything that we saw that appeared down here. The only difference is this square bracket, which I will talk about momentarily. So I just added random information to this table. I put a different label and a different caption. And so let's scroll in our document to try to find it. But before we do, just take a look. This automatically renumbered this to table 2, and this was also renumbered to table 2. So scrolling up, let's look. We find table 1. You might notice there's no horizontal lines anywhere, and that's because we never wrote in the horizontal lines ourselves. So let me add H line here, here, and here. Recompile. I had an error thrown when I tried to recompile that. And let's see, missing number treated as 0, misplaced, no line. So this is something that I don't really know what this means, but if I look, we're not getting the H line to appear where we want, and we're getting this word height suddenly appearing. So what I'm going to do is I want it to be underneath this entire row. And right now I have it on the same line as the rest of that. So I'm going to add the 2 backslashes and try to recompile that and see what happens. And that did work. Let me just compare with what we had down here. That's exactly what was written down here. You can play around with the aesthetics. You can add multiple horizontal lines, and multiple horizontal lines will appear. But what's important to note is that introducing an earlier table up here automatically changed the reference that we made to the table of random values that's now listed as table 2. The same type of thing can be applied to equations. So let me find a random equation. We're going to use this equation that I wrote in line 42. I'm going to add a label, specify the type equation, so EQ, and I'll say trig rule for sine squared. Then if I want to refer to that equation somewhere else in the document, down here, if I type in the ref command, you can see that the equation trig rule for sine squared appeared. I'm going to click it. And just upon recompiling this line, we see that equation 1.3 was written in. And let me check within the document and make sure that that's exactly the equation that we were dealing with. Indeed, it is. You can also see I used the inline math here using the parentheses and sine squared x. If we go back to the table that we manually wrote in, table 1, I noted before that there were these square brackets that appeared, and these square brackets are a positional argument that we could put in to let Overleaf know where we want the table to appear. So the argument that you could put in here are T for top, B for bottom, and H for here. Top and bottom are pretty intuitive. They go to the top or the bottom of the most local page that works with the flow of the rest of the writing. So if I put B here, we scroll up. Let's just look at where the table is right now. It's up at the top of this page. If I recompile it with that argument B, we can see that it's now moved down to the bottom of the page. If I were to put H here, let's see what happens. No, it just moved up to the top of the page because you can see that I have it immediately after this box around x equals 4 and 1. And so that's exactly where it appears. And so it's also just still up at the top of the page. So nothing really changed with that. We can also add an exclamation point after these positional arguments. And what that does is it really tells Overleaf, I really, really want this table to be here, so put it here. Typically, what I end up doing is I always include the exclamation point for the top or the bottom. I typically don't really use the H command, but it's something that you should know at least exists. Adding images to the document is very similar to the way that we had to add a table to the document. We have to use the figure environment the same way that we had begin table. We're going to have begin figure here now. So begin figure. If we click enter, we can see that automatically a couple of things have appeared. We have the same command from before, this centering, so the image will be centered to the page. Then we have this include graphics command, and you can see that images backslash taylorswift.jpg is what automatically appears. So I'm just going to click it. I'm going to put the caption as Taylor Swift at the Golden Globes, and we'll label the figure as Taylor Swift. If I recompile, we see, before I even scroll in the PDF, we see an overfull box that appears, a little warning. The overflow in the horizontal direction is almost 900 points too wide, and the float is too large by 1300 points. So let's look at what this image looks like. It is gigantic. You could barely see her. This takes up way too much space. So what we can do is right next to this include graphics, if we add square brackets and add the command width equals \text width and recompile, we can see that that got better. It's now made the image the same width as the total width that text would take up if we were writing. So just like scrolling up a little bit, you can see like here, it aligns to this, and this in there and there. But it's still too big vertically. So what we can even do is if we make this 0.5 text width, that shrinks the image even more. And finally, we have no warnings, but you might note a couple of things. So this is centered in the complete middle of the page, but we can add a positional argument the same way that we did to the table before. Right next to the begin figure, I'll add T exclamation point and recompile. When I do that, you'll see nothing changed. Why is this? Since there was not enough room for the image to actually be on the page before, no matter what, it'll be centered on the next page. So what I'm going to do is I'm going to shrink the image down even more. I'll go 1/4 of the text width and recompile. Now the image is small enough to be on the page and it is positionally at the top. However, since the table came first, the table is what appears completely at the top and the image is second. I could also make a reference to the figure the same way that we referred to the table or the equation. And we see refer to figure 1 appears just by using the reference to the image that we wanted. Something else that I want to mention before moving on is that we could actually change the width and the height to be specific things. So although I went with the width specifically, I can add a comma and say that the height equals 30 millimeters. And if I recompile that, you'll see this squished the image down so that now it's 30 millimeters and the width is 1/4 of the text width. So it's not the best practice to specify a width and a height and rather just specify one of them, and whichever one you prefer you can use. I also just want to note that we can add images using the visual editor the same way that we added the table before. So I could click where I want it to go. Let's scroll up somewhere. We'll insert a figure from project files. We'll make it the same Taylor Swift picture, 1/4 of the width, and we'll insert the figure here. Then we have to enter a caption and recompile. And we can see a few things have changed. First of all, the image of Taylor Swift that we originally added has now been pushed onto another page. Again, it's centered because it doesn't fit on the page beforehand. And if we scroll up and look for the other picture of Taylor Swift, here she is. This one is now figure 1. And where we had the reference before is now changed to figure 2. So it's referring to this image now. A little confusing because I'm using the same image, but I hope you understand the general gist of it. Let's switch back to the code editor and let me open another Overleaf document that I have to show you the wrap fig and subfigure environments, which are other environments that you might use. So this is an old paper that I wrote for one of my classes. And you can see that here I have 2 images next to each other. So if I double click to go to that place, this is where we have the subfigure environment. So let's break down exactly what's written here. I'm just going to add some spaces. So within the figure environment, I put centering, then added another environment, a subfigure that is just under half the text width. And that's what allows the image to show up side by side like this and have there be 2. I've included the image the same way that I did in the standard figure environment. Then I added a horizontal fill, which then is immediately followed by another subfigure that again is just under half the text width. That's what positions these 2 next to each other like that. Suppose I wanted to add another image, another figure, so that I had 3 images side by side. I just copy pasted this same figure 1 image, but when I just recompiled, it repositioned everything vertically. And this is actually because I've added these spaces between the H fill. And so if I get rid of these and recompile again, let's see what happens. Just as before, we have these two images next to each other, but this third one was pushed onto a new line. And that's because it overflows, because these two take up the majority of the line. So if I want three next to each other, I might change this to 0.3 text width and recompile that. And there we go. We have all three images then right next to each other. So this is using the subfigure environment within the figure environment. The other environment that I mentioned was called wrapfig, and we can see that here. Wrapfig allows the figure to be positioned next to a little bit of text. So here I've put the image to the right of the text. We still have a caption that corresponds to it, and let's look at the code itself. So going to that point in the document, we have the wrapfigure environment where I've specified that I want it to be to the right and I want it to be just about under half the text width. Then I center the graphics to be 0.4 of the text width. This is something that I actually had to play around with a lot to actually get it to look like how I wanted it to look. So just know that wrapfigure is in an environment that's very finicky, and I don't really recommend using it unless it's absolutely necessary. The reason that I used it in this case was because I had a page requirement that I needed to meet, and moving the figure down to the bottom of the page resulted in it bleeding onto an additional page. And so I figured if I were to wrap the figure, it might be a little bit better, but I don't typically use this, and I do use subfigure a lot. In order to actually use wrapfig and subfig, we have to add the wrapfig caption and subcaption packages to the preamble of the document. And you can see here, this is a document that's a little bit neater in the way that I've organized the preamble. So what I'm going to do for all of you, I'm going to link a LaTeX document that has a preamble that's neatly organized, has all of the necessary packages that you might encounter, like ones that we've talked about in this video specifically. That way you can start to write how you want to write and not necessarily be bogged down by all of the nitty-gritty details, and you can just instead use the commands as we've discussed. Now, that really just about does it for the overleaf discussion that I wanted to have. But before I finish completely, I wanted to talk a little bit about MATLAB and creating figures in MATLAB that are a little bit more presentable. So I've just written a few lines of code that when I run this will plot sine pi x, cosine pi x, and x cubed all on the same plot. So I'm just going to run it, and we see that that's exactly what appears. We have three different lines corresponding to each of the different functions. So here I've added the different colors that I want, black, blue, and green. These two dashed lines will make the entire plot be dashed for this specific function, the sine of x. I've also specified the line width to being 2 for all three of the lines that are in this plot. So when I run this, we can see that all of the lines have thickened and the black line is dashed. The next thing I'm going to add is the command grid on. When I run this, we have a faint grid that appears in the background. Next thing I'm going to do is write set GCA, comma, font size, comma, 16. When I run this, we can see that the font has increased on the X and the Y axes. Now let me add some labels. And I'm just letting the X label represent time, saying that it's measured in seconds. The Y label be the position measured in meters. When I run this, they are also now of the same size, font size 16. I recommend using a font size of 16 in this scenario whenever you're adding an X label or a Y label. And so set GCA should be something that you use every single time that you make an image that you are going to put into a lab document. Next, let's add a legend. And here I'm going to make the legend be sine pi x, cosine pi x, and x cubed. And the way that I'm going to get this to actually look good is by using some of the LaTeX knowledge that we've built up to this point. So let me type in. This might be the general way that someone might create a legend for this plot itself. And if I run it, we can see that it doesn't really look that good. We have the x cubed looking like it should, but the pi isn't represented as a symbol. And so the way that we could go around this is by using an additional command to the legend where we say that the interpreter is LaTeX. And now we can use inline math, so the dollar signs, and add the backslashes to the different commands. So let me just add it to the sign and leave the cosine alone and see what happens. We can see that this did a couple of weird things that you might not expect. The cubed is now not in the superscript of the x, and it has now been replaced with just a caret. The sine and the cosine have now also transitioned into that same serif font that we were seeing before. And so let's actually completely clean this up. Running this then gives us exactly what we wanted. Now I'm just going to reposition this to the left corner by adding an additional command, location. And here you can see that there's a bunch of different locations that you can choose: north, south, east, west. In our case, we want northwest. We'll run this, and that's exactly what we see. It's now moved to the left corner. That's great. We can use the LaTeX interpreter also in the X label and Y label. So suppose that instead of this representing time and position, we had it representing other quantities, and we needed to use symbols such as alpha or square roots of some kind for whatever reason. If we just add the comma, interpreter, LaTeX, I've added labels that now make absolutely no sense to the situation, but I just want to show that indeed we get it to look like we want it to. So at this point, we've crafted a pretty good figure, and you can either screenshot this to add to documents, or if you want to, of course, you could do a save as and save this as a JPEG or a PNG. However, what I typically do, especially with something that might be a little busy, is I want to make the quality a little bit better as I'm saving it. So in File, if you go to Export Setup, go to Rendering, the resolution in dots per inch is typically set to auto, but I will always change this to somewhere between 800 and 1200. Let's let it be 800 for now. I'm going to click Apply to Figure, and we're going to give it a second. Once Restore Figure goes from this unclickable gray to being clickable, that's when we'll know that it has actually been applied to the figure. So that didn't take long. I'm going to click Export, and let's save this now as a JPEG. And we can see that it's now appeared on the left-hand side of the screen, so we know that this has actually been saved at this resolution. So if I left-click to open outside of MATLAB, we can see that the figure is big, and that's good because that means that we have high resolution. And if we add it to something like an Overleaf document, we know that it won't get muddied up when we try to resize it. So I definitely recommend taking the extra time to export the image in a higher resolution if you're going to add it to something for a lab report or a report in the future. So with not much additional writing other than line 12, which is a new command that you might not necessarily add to all images, all we've really done is add the LaTeX interpreter on the different labels and legends. And in most cases, this is enough to qualify a really good figure at the end of the day. Before we end, I just want to show the template that I will be sharing with y'all, and it might have a little bit more when I do share it with you, but all of the packages that we talked about are added up at the top, where I have specified to number the equations within the sections. There's 20 millimeters of margin space at the top, bottom, left, and right. And what's more is if you click on the samples.tech, there are different things that you could just copy paste into the actual main file so that you can have just one image, two images side by side, three side by side, or two images, four images in total, two at the top and two at the bottom. So you could just copy paste these into the main document and use them. But that just about does it. I hope that this was beneficial for you. I really encourage you all to at least check out Overleaf. If it's not something that you necessarily want to use for the lab reports, I completely understand, but I do think that you should at least spend a little bit of time familiarizing yourself with it. Maybe try to write part of your homework on Overleaf or using LaTeX, because again, the more familiar you become with it now, I think the better it will be in the long run for all of you. It's something that I wish I was exposed to a little bit more formally during my undergraduate education, because I was really just thrown into the deep end and expected to learn it on the fly, which is a good way of learning things sometimes because it kind of forces you to catch on really quickly. But it's something that is definitely worthwhile. Not to mention that I think it's a lot easier to use Overleaf than it is to try to structure Google Doc or Word in a way that actually makes equations look good. So again, I highly encourage you to use it, even if it's not for the entire lab report. If you write equations in Overleaf and screenshot them and add them to your Google Doc or Word document, I think that will even significantly improve the overall readability of the lab reports themselves. But again, this isn't something that we're necessarily requiring. Okay, well, please let me know if at any point y'all have any questions about this. This is something that we can talk about during lab hours or TA hours in general. But I wish you the best of luck with learning this if it's something that you do end up doing and using it throughout the duration of this quarter.